All right, look up, please. Okay, this is number 5 from the blue. So you'll need a nice clean page in your notebook. Okay. As I keep emphasizing, you have definitely left the unit where you don't really have to know the why so much. The unit 2 where you just learn to use the rules. You have to keep track of the reasons you're doing things. One sure method of getting a bad test score is not knowing why you do something. If you don't know the why, you're just guessing. Okay, we talked through problem 5. Make sure you ask as much as you need to ask to keep track of why we're doing what we do. There's methods, there's techniques, but you've got to keep track of the why. They give you a function f, and they ask when f is increasing. Okay, if we had a graph of f, that would be really easy. But because you're not allowed to use a calculator, not so easy. Most people do not typically remember enough from a previous class to graph this accurately enough to answer the question. So what I'm going to teach you right now is a method known as a sign pattern chart. The sign pattern chart goes with Danica's chart, so make sure you think of them together. Sign pattern chart, Danica's chart, okay? Unfortunately, a student didn't come up with the idea, so we couldn't name it after the student. I suppose if somebody was kind enough to make a really nice frame picture for my wall, we could call it your chart. Okay, sign pattern chart. What we're doing is, I want to find when f is increasing. But because I don't have a graph, I think of Danica's chart, and I remember that f will be increasing. Remember, precision is key on this next test. You have to make sure you know what an x-coordinate is, what a y-coordinate is. You don't get them mixed up. F will be increasing when the y-coordinates of f go up. But that happens exactly when the y-coordinates of f prime have positive values. So that's what I'm thinking, is to figure out when f goes up, I need to figure out when f prime has positive y-coordinates. Okay? Okay, the next thing I'm going to write on the board is not real. It's just a guess. Okay? It's just a demonstration. It has nothing to do with this specific problem. It's just a general idea. So don't associate with what I write with the problem. It's just a general idea. What I'd like to figure out is this. If I could draw a line, and on this line I could write down every possible value x could have. So I would start at negative infinity, and I would go to positive infinity. And for all these different x values, if I could find out what is the y-coordinate of f prime at each of these different x values. So suppose I can find that out. Suppose I discover somehow that at x equal 3, the y-coordinate of f prime turns out to be 0. But over here, the y-coordinate is positive. And over here, the y-coordinate of f prime is negative. Okay, if I had that information, I could answer this question. Because I could say, when the y-coordinates of f prime are positive, f will be increasing. So I could write on my paper, since f prime is positive for all x values that are less than 3, therefore f is increasing for all x values less than 3. Anyone want me to talk more about this idea that if I had this information, and with Danica's chart, I could answer the question of when F is increasing? For hands or waving or anything. Everybody feels good about this? Cool. Okay, this is what's known as a sign pattern chart. Okay, it's simply a chart showing X and Y values, but instead of having numbers, it only has positive and negative. So it's a lot easier to build because you don't have to worry about any real numbers. It's a lot quicker to do the computations to figure out the positive and negative than it would be to find numbers. So this is what we would like to do for this problem. We'd like to create the correct sign pattern chart that is associated with this problem. Question? Awesome. Okay. One caution about sign pattern charts. When we build a sign pattern chart, we are often comparing a positive value to a negative value. Don't ever try to build a sign chart. Like if you're building a chart and you find yourself thinking, a positive value added to a negative value, you're making a mistake because you don't know the result. If you're adding a positive to a negative, you don't have any idea what you get. So don't ever build a sign chart where you find yourself adding signs. However, we will often build a sign chart, not always, but often, where we are multiplying signs because the result is known. We often will build a sign chart where we are dividing signs because, again, the result is not uncertain. The result is known to be negative. Do you need me to repeat any of that? This is one of the most common errors. People will build a sign chart and say, what's wrong? I can't get it to work. I look at their work and I'm like, oh, you're trying to add signs. Can't do that. So. Questions? Another warning. I was helping someone this morning from A1, so they had this discussion yesterday. So I was helping someone from A1 this morning, and the reason he was stuck is because instead of having nice, neat, organized, well-labeled notation, he had a pile of stuff. Like I can't really, I look at his work and I'm like, I have no clue what that is. Like I see some pluses and minuses and numbers, but there's no organization at all. I cannot help. And that's why he couldn't do it either. As soon as you back up, have good notation, you'll be able to do it. So be organized. Did I erase this? Cool. Okay, so we're going to make a sign chart of, another common error. People will make a sign chart without knowing why they're making it. You don't want a sign chart of F. We want to know when F prime is positive. So don't make a sign chart of F, make a sign chart of F prime. So know what you're charting. So first thing, to make a sign chart of F prime, we do need a formula for F prime. So let's erase this. That was exciting. Really good eraser. That was to choose the right button. Shoot. Here we go. All right, that was fun. Okay, so we need the derivative. So that part you already know how to do. So F prime is going to equal second function multiplied by derivative of the first. But the derivative of the first is simply 2x. Just wave at me if you need more detail there. Okay, now we write down the first function, x squared subtract 3. And then we have to take the derivative of e to the negative x. So we get 2x d to the negative x. This computer is struggling. Plus x squared minus 3. This would be the derivative of e to an exponent is e to the exponent multiplied by derivative of the exponent. Wave at me if you need to do more detail. Just make sure you don't write it like this. You write it like this, so we know it's multiplied. Points? Anybody else? Oh. Okay, so here we go. So here's f prime. Okay, I want to make a sign chart of f prime. This is like a lot of AP problems. You think big picture, which is what we were doing when we said, okay, to figure out when f is increasing, I need to see when f prime has y coordinates that are positive. Therefore, I need a sign chart of f prime because I have no calculator. That's thinking big picture. Then you think little picture. You do little steps. Here are the little steps. I'm finding the derivative. I'm finding f prime. Now I'm back to big picture. I need a sign chart of f prime. Okay, this equation is far too complicated to easily create a sign chart of the whole equation. So what we do instead is we're going to break this into smaller pieces, do a sign chart of each piece, and then put it all together. Wait, if you need me to say that again. So if I try to make a sign chart of f prime, it's just too complicated. So what I'm going to do is rewrite f prime as small pieces, do a sign chart of each small piece, put it all together. 2 points. Anybody else? Okay. But I cautioned you. You do not want to take this piece of f prime and compare and combine it with this piece because you're adding. And you'll end up trying to combine a positive with a negative by adding, and you won't be able to determine the result. So you don't make a sign chart with these two terms. You don't ever make a sign chart with terms. Always make a sign chart with factors, because factors multiply. Question? Maybe nobody ever noticed this. I think it's ironic that when you're in elementary school, you learn how to add first, and subtract, and multiply. And most people, like, the multiplication is just more complicated. It's like, oh, let's go back to addition. It's easier. But when you get to algebra, it switches. Everything is often easier when we're multiplying. It's when we're adding that's a pain. So, interesting.
So I just have a question. Would you not want to simplify it, I guess, and pull up the e to the negative x?
No, you're right. Hit 2 points for Trey. It's exactly right. I don't want to try and make a sign chart with these two pieces because I can't. So what I do instead is rewrite f prime by factoring. So Trey noticed perfectly. This term has a factor of e to the negative x. This term also has a factor of e to the negative x. So I pull those factors out of each term. So Trey, what factors remain here?
2x.
Plus?
Negative 1 and x squared minus 2.
3 points for Trey. Question? Cool. Okay, now I do have two pieces here. This piece is simple to make a sign chart of. This piece, still a bit complicated because it's a quadratic. So I'm going to keep trying to find smaller pieces. So let's see, f prime, e to the negative x, 2x, minus x squared plus 3. On the AP test, quadratics are almost always factorable. Almost. I have seen places where they were not very kind, and it was not factorable, but mostly they are. I would prefer not to have this be -1, so I'm going to factor -1. So now I have -1 multiplied by e to the negative x. Putting this in quadratic order, it would look like this. We need to give more detail there. Let's wave at me. Please, Ray.
Why would it be -3? Shouldn't be.
So factoring a -1 out is the same thing as like multiplying everything by -1. So here you go, 2 points. There you go. So this will factor. So now we have f prime. I always look here. I always ignore the middle. I look here. 3 and 1. Now I multiply. This will make 3x. This will be x. I need them to add to be -2x, hence negative and positive. Questions? Awesome. Oh, please, Keely. So what you look for is two things are going to multiply to become x squared. X and x. Two numbers are going to multiply to be 3. 3 and 1. Now I just multiply it out. So I do the rainbow deal and just make sure it works. 1. There we go. Cool. Okay, we now have 1, 2, 3 factors of f prime. And we can build an individual sign chart for each factor because each factor is pretty simple. Question? So let's get a fresh page here. So here's my f prime. F prime is -1 multiplied by e to the negative x multiplied by x plus 1 multiplied by x subtract 3. So I draw a number line. The number line represents all possible values of x. I want a sign chart of f prime. That's what I'm trying to get. So to get the sign chart of f prime, I'm going to first make a sign chart of e to the negative x. Okay, you all need to have flashcard memorized. E to any exponent is always positive. In fact, any positive number to any exponent is always positive. Never negative and never 0. Question. So e, here's some quick examples. So e raised to any exponent, like e squared. Well, that's just 2.7-ish squared, so that's definitely positive. If the exponent were negative, I could rewrite this as 1 over e cubed. But because e cubed is positive, this would still be a positive value. If the exponent were 0, 2.7 to the 0 power is 1. So that's still a positive value. So there's no way for me to choose an exponent of e that will cause the result to be anything but positive. So e to any exponent, always positive. Points for Bryce. Kinda. It's actually a case where it cancels a pretty decent word, actually.
But is that only like natural log to e, or could that be
Only natural log to e. Oh, no, it actually goes both ways. Natural log of e to any exponent is simply the exponent. E raised to the natural log of whatever is just the whatever. So both of these formulas are frequently required on some AP test problems, so we need to know both of them. Two for KLA. Anyone else? Sweet. Back to here. Okay, so I want to make a chart of e to the x, e to the negative x. But that's really easy. It's just always positive. However, I'm multiplying the e to the negative x by a negative 1. So together, they would always be negative. So I make my chart show that. The chart says if x is negative 100, this will be a negative y value. If x is 0, the value of this factor will be negative. If x is positive 10, the value of this factor will still be negative. So it doesn't matter what x value you pick. Now remember, this is just a piece of this. So all we're doing is we're talking about f prime. We're just doing it in pieces. Don't lose track that we are talking about f prime. We're saying that if you plugged in negative 10 into f prime, this portion of f prime would have a negative value. Don't lose track of that. We need me to repeat that. Cool. Now we're going to work with this part of f prime. So that's a little more complicated. Not much. So I have x plus 1. Okay, you always want to start with finding the value of x, which will cause this factor of f prime to equal 0. Just say it. What x makes this 0? Negative 1. Okay, the scale here isn't really important, other than it's really important you spread things out. If you bunch things together, you make mistakes. People do it every year. So spread it out. So let's see. Just get a little space, negative 1. So the way you read the chart is, if I took a negative 1 and plugged it into f prime, so I put a negative 1 here, here, and here, this part of f prime would have a value of 0. Make sure you line up the zeros. That's also a really common error. So you might even want to like draw little dotted lines to make things are lined up. The vertical alignment is critical. Questions? Please. Perfect. So any value over here, x being less than negative 1, this becomes a negative value. And the good news is for all of the sign charts we make for our class, in this section that's left of the 0, it will never alternate. So you can literally, if you're uncertain, just test one x value, find that x value, the rest will all match. Cool. So then you come over here and test. So well, if x is 0, this is positive, that means for any of these x values, this will be positive. Anyone want me to repeat anything? Pattern for x minus 3 is very similar. Three. 0. Here we'd have negative. Here positive. Questions? Awesome. Okay, here's how you put it together. Okay, the chart says that if x is negative 10, this portion of f prime right here will be a negative value. That's why we wrote it down. When x is negative 10, this portion of this factor of f prime will also be negative. This factor of f prime will also be negative. That's why we wrote down the chart. Because now we can say when x is negative 10, these three factors just multiply. So these three negative values multiply, and f prime is actually negative whenever x is some negative number. That's how the chart is built. Question? You need me to go through that differently, just wave at me. So, I'll talk with you, it always works way better. So are you comfortable that for all of these different x values, this is simply negative? Good. We also figured out that for like over here at -5 or whatever, that this was negative. We wrote it down. We also figured out that this was negative. So if we're plugging in -5 into all these x's, we don't really have to use this at all. Because we already know when we plug in -5 here, the result for each piece will be a negative times a negative times a negative, which is some negative. Better? 2 points. Anybody else? Cool. So these are all negative. Negative, oh right here, -1. When x is -1, I wrote down that this factor will be a negative number. I wrote down that this factor will be 0, and this factor will be a negative number. Multiplied together, the value of f prime would be 0. Question? Same method. So I now have what I wanted when I started the problem. I can look at f prime and say f prime is positive between -1 and x equal -1 and 3. So when f prime has positive y coordinates, that's the same span where f will increase. So that's sign chart method. Question? Please.
So just real quick, on that like second, like in the middle part.
You know what talk second here?
In the middle part, it's because there's two negatives to make it like a positive and then multiply both.
You're good. 2 points. You know? The key is, look, the key to the sign chart is remembering. When I make each row, I am working with f prime. I'm just working with a little piece of f prime. And I'm simply saying, I'm going to plug in all kinds of x's into each piece, all of these different x's. I'm going to figure out what happens to each piece. Then I just put it together. So. Cool. Let's go to, stop that.